Hello and welcome to this video module titled Examples of Alkane Reactions, filmed at the OSU-Cascades Lightboard Studio. In this particular example, we'll use an alkene mixed with a dihalide and water. And it's important that that we recognize that water is in there and that water is the solvent because that will take place as part of the reaction. So first step of this reaction mechanism is the nucleophilic attack, cleaving the dihalide, which then allows another bond to form from the chlorine in this case. This forms two intermediates in this situation because the attack can occur in the front from the chlorine to create the cyclic chloronium ion, placing the methyl group in the back, or the opposite, where the cyclic chloronium ion is formed in the back, and our methyl group therefore is forward. So here's our two intermediates that form initially from the first step of the reaction. Yes, we have chlorine ion around, and if water wasn't there, we could have that chlorine attack and have the dihalide reaction. In this case, however, we do have water as the solvent, and because there is so much of that around, that is the next reaction and not that of the chlorine ion. So in either of these cases, what we have to remember is the subsequent attack in this next step results or comes from the opposite direction of the cyclic chloronium ion. So in this case, the water will attack from the back side, and in this case, the water will attack from the front side. And in both cases, what you see is the water is not attacking the least substituted carbon, rather it will always attack the most substituted carbon because of the partial charge buildup that occurs. That's the favored reaction. So as we take this forward into the next intermediate, actually I forgot an arrow, so we need to show that the cyclic chloronium ion bond is breaking. And so what we see in the first one is that our methyl group moves to the forward position because our water attacked from the back position, and our chlorine here is still out front as it was to start. Likewise, on the other side, we get the opposite situation where now our CH3 group is back, our water group is forward, charged because that oxygen has 3 bonds, and the chlorine group is still in the back there. And these are still intermediates because we have these plus charges. So we get both of these stereochemical intermediates to form, and then the final step for each of these is deprotonation of the water to form the final alcohol. Some base can come along and pick that up. We can call that the Cl- that comes and grabs that H, kicks those electrons there to form the final product, or one of the final products, which is this stereochemistry. The CH3 group is out, the chlorine is out, and the alcohol group is back. And the corollary over here, we have the opposite situation now. We have the CH3 group back, we have the alcohol group forward after the deprotonation, and we have the chlorine back. Let's do that deprotonation here. We said the chlorine adds. You could also say that the water is what comes in and grabs that other proton. Either of those acting as a base is appropriate to lead us to the final products. This is your halohydrin reaction. This is the water, this is the halogen. And so what we have to recognize in this particular reaction is that yes, we have the dihalide, but we also have water as our solvent. And so as the solvent, it can react. And because there's so much of it around, it will react. And then finally, we should recognize that we get these products in a 50-50% because there's equal opportunity for that chlorine to form the intermediate in this reaction. So what we have here is your halohydrin reaction example for the reaction with the alkenes.